All right, let's do some associative rule mining in R. And obviously we're going to use the arules package. So I've already loaded it in to save a little bit of time, but this is the code that you would expect I ran. And now let me start using the data groceries, which is obviously already built into the system. And I'll actually store that just so that I don't mess it up by accident. There we go. Now I can explore what that looks like by, for example, doing an inspect on it. So we can see that G, or groceries, are the same thing right now. It's a transaction data set, which means we can pass it directly into arules. And what we can see is that the first basket is here, so fruit, some bread, some margarine, and some soup. The third basket, for example, only has one item, milk. And the fifth basket has some other types of vegetables, different types of milk, and some bakery product. We can also take a look at maybe length. Spell it right. So this represents, right there, the number of baskets we have, 9,835 baskets. And we can do more generally. Maybe we should have done this first. I can take a look at the structure we have. And we can see we have these @ signs, which I'll talk about in a second. But basically we have a matrix that we call data. And then we have something called item info, which has 2 levels of factors. And this describes, if you will, kind of what people are buying at 2 levels of detail. And we'll kind of show that a little bit more, but that's kind of what we have. So we have kind of the matrix, which shows the items, and then the information describes like what the items are. And then the @ sign is kind of like $, except for more advanced data classes that we have. So let me get access to data and show you how to do that. You just do that, data. So now if I do structure of data, you can see it's that sparse matrix that we were talking about. So now that we have the matrix, we can do something like, what do you think this row actually represents? So when we generate means, what does that variable mean? Well, let's take a look. Structure of means. So we have, for each possible item, the percentage of time that it occurs in the cart. 5%, 9%, and 0.05%. So you can get an idea. So what we've done is we're kind of doing some basic analysis of the transaction data set directly in R rather than using the package that we would be using arules later. You could take a look at some additional items. So in addition to the data, which is that sparse matrix, if you remember we had the item info. So 169 items. That shouldn't be a surprise because that's how many items there were that people had in their carts, possible items they had in their carts. And again, there's these variables of what they are, kind of levels of detail, if you will. So we could take a look at this. Item info. So the first element was a Frankfurter at 1 level of detail, if you will. The higher level it's sausage, and at the kind of the top level it's meat and sausage. You can see you can kind of group items by different levels, if you will. You can also take a look at it the other way around. So this is all, obviously, all the top items, right? So all of it, if you will, from the label. So we can store this. We take a look at all the labels, for example. Frankfurter sausage, these are the different names that we've been using. And we could do the same thing for maybe with a level 2 information. see again the secondary detailed information. So now we've got 3 different variables. We actually can create a data frame with kind of summarizes our transactional data set. So remember how we create a data frame and we have the means, we got the labels, and we have the level of more detail, which I think I just called levels. There we go. And just take a look at what one of these guys looks like. So we've got Frankfurter was in about 5.8% of the baskets, in the name of Frankfurter, and the higher level is sausage. You can kind of take a look at, I don't know, the 10th item. So there's something called, it's just pork, and one more just to make it beef. Okay. Onions. So we can get a feeling of the different items just by looking at the data frame. Now we do that. Now let's actually filter the data frame. Here, I'll call it a different one to keep them both. So what do you think this line code does? Let's take a look. As we can see, it's sorting based on the mean, right? So that's based on, we said order it based on that. So we just have an ordered list of the items that happen the most, and then we have kind of what the label is and kind of the higher level description of it. And lastly, we can kind of maybe just look at a subset of it, which is show me all the items, perhaps that occur more than 8% of the time. Here we go, there's not that many of them. 2, 4, 6, 8, I don't know, maybe 15 or so. Now we didn't tell it to sort it so we can see all of them, but we can see whole milk is there. We can see sausage. So by doing this, we get a feel for what occurs most frequently and what occurs less frequently. Now let's actually start to do some work in the A-rules package to understand this data, not at this detailed matrix level, but maybe at the rules level. So I'll go in here and we'll go right away into, let's do a tapply. One more thing just to take a look at that. Let's just go straight to this. I don't want to deal with that. So the first thing we can do using A-rules is do an item frequency plot. And here we have the different frequency of items, the most occurring items. So that's similar to the data frame that we created, actually. And let's start creating rules, and we'll give some support rules and confidence. Again, it's generating S4 objects. We have that @ on it, but we can see 120 rules were generated. And we can then rerun it, increasing the support. And we went from 120 items down to 15, or 120 rules down to 15 rules. So 15 is a reasonable enough number. We can actually expect those rules. Again, we're trying to predict, in this case, whole milk. And curd and yogurt. Curd is, I guess, I don't know, some dairy product. As a predictor of buying whole milk with the support level and kind of the varying different support levels. So here's a fairly high support level. Buying vegetables and yogurt predicts whole milk. Try to run it again. This time maybe we'll generate a lot more rules because we lowered the support and the confidence. So obviously that means we're going to create more. And here what we did is we plotted all the rules. Since we have so many, the plot is probably a better way to represent it than just visually looking at the rules. But you can see it ranges in terms of the level of support, as well as the confidence, and then the lift. The red ones have more lift associated with it. So it's like, take a look at a subset of these just based on, for example, lift. So now we have high lift. So if you think about it in this picture right here, we're going to say above 3.5. So it's kind of all the red ones. It's going to be easier to take a look at. There you go. So now it's rescaled, right? Obviously the X and Y axis is rescaled to fit the data, and all the lift is high because we've kept that. And we can take a look at these rules. So there's 9 rules that fit this criteria. And we can get a feel for both what's being predicted, root vegetables, based on this basket. Same thing for root vegetables based on herbs. And we can see the support is pretty low, the confidence is reasonably high, and the lift is very high. That's all because we had high lift for everything. Now we can kind of take a look at where there's support. Plot those. No rules. Let's go back and look for beer. So we have beer. We'll try to predict beer. And again, we have confidence and support. So pretty low because of kind of this data set. You can inspect those rules. So we can take a look at, for example, maybe one with a very high confidence level, 0.9. That's very high, for example. Support doesn't happen that often, but when it does, you know it's going to occur. So if people buy liquor and red wine, they're going to buy beer. So I guess they're having a party. See if there's any other ones that are really high. No, that one's by far the highest. This one might be the second highest in terms of confident. And again, liquor, you're going to buy beer, but you would think that not all the time. We can do the same thing. We can plot these rules. Not that many rules, but we can see the huge difference in lift associated with many of the ones with low support and low confidence. Here's one, for example, very high confidence, very high lift, and some support. We can drill in a little bit more detail. See here what we did. We kind of zoomed in on that one with very high confidence. And again, it's what I identified at the very beginning. You have liquor and wine, red wine in particular. There's a very high likelihood you're going to buy beer. So maybe we'll end by actually plotting what that looks like, which is a different type of visualization. So here's the plot for the 15 rules that he has, so not just that one, but the 15 of it. And you can see what's driving bottled beer. So you can see this red and blushed wine over here, liquor, so the size of the circle obviously is helping to dictate. Let me show you just a little bit bigger. Here we go. So we have the lift being shown by the color, and the size of the circle is showing the support. We see the ranges for that. And we see the direction of what's driving beer. So for some people, this visualization is very intuitive, and for others, including myself actually, this doesn't really help me too much, but it kind of gets back to the visualization week where some visualizations are very useful for some people, and the same visualizations are not useful for others. So it's really a question of sometimes it's better to show the rules, sometimes it's better to show the visualizations, sometimes it's better to do a combination of both. So I think we'll pause there for today.